Welcome to Ask and Learn.
So in this question, we have a geometry ABC, which I have drawn here, having height h and length along the x-axis is a. So I have taken an element of width dx here, dx width, and the center of this element is located at xd comma yd. Okay, so from the geometry I am taking two triangles ABC and DBE, which are isoscales. Isoscales. So from the properties I can write DE divided by AC equals to DB divided by AB. Okay, so from the geometry I can put the values as DE will be h minus y divided by h equals to a minus x divided by a. So from here I can obtain y equals to h by a into x. This is our equation number 1. We will use it in the next upcoming equations. Okay, so from the geometry again, the elemental area dA can be written as dy multiplied by dx, and which will be equals to h minus y multiplied by dx, h minus y multiplied by dx. Okay, so from equation 1 I can put the value of y into this equation to obtain dA as h minus h by a multiplied by x into dx. Okay, so now integrating it on both sides to obtain net area from 0 to a, and this will be integrated from 0 to capital A. So from here I can obtain integration dA as equals to hx minus h by a x square by 2, and the limits will be 0 to small a. Okay, so by putting the values of limits I can obtain the result will be equals to dA, integration of dA will be equals to ah by 2. This will be our equation 2. We will use this equation again in the upcoming results. So now we will determine x vector, x bar. X bar is center of mass or centroid along the x-axis. So for the calculation of x bar, I can see from the geometry that xd bar equals to x. So I can write xd bar into dA equals to integration xd bar is x, and dA from the equation is h minus h by a multiplied by x into dx, and this will be integrated from the limit 0 to a. Okay, this will be integrated. So from here I can write xd bar multiplied by dA equals to, by solving it, hx minus h by a into x square dx, 0 to a. Okay, so from here xd bar dA integration will be equals to h x square by 2 minus h x cube by 3a, and the limit will be from 0 to a. So after solving it, this equation, xd bar into dA will be equals to 1 by 6 a square h. So now x bar is given as integration xd dA xd dA xd dA divided by integration dA. So xd dA is 1 by 6 a square h, and from the equation 2 integration dA is ah by 2. So from here x bar will be equals to 1 by 3a, or simply a by 3. This will be our value of x bar. Okay, so now we will solve for the y bar. Y bar is centered along the y-axis. So from the geometry, yd will be equals to h plus y divided by 2, and by putting the value of y from equation 1, I can write h plus h by a multiplied by x divided by 2. So from here yd will be equals to h by 2 1 plus x by a. So now integrating yd bar multiplied by dA to obtain results. So yd bar is h by 2 1 plus x by a, and dA is h minus h by a into x multiplied by dx, and this will be integrated from again 0 to a. So after solving this equation by multiplying and integrating and all, the yd bar multiplied by dA bar will be equals to, this will comes out to be 1 by 3 h square multiplied by a. Okay, so from here I can write y bar as integration yd bar into dA upon integration dA, and yd bar dA I have obtained as 1 by 3 h square multiplied by a divided by dA is ah by 2, or 1 by 2 ah from equation 2. So from here y bar is 2 by 3 multiplied by h. So the center of mass coordinates are x bar comma y bar, and which will be equals to a by 3 comma 2h by 3. This is the final result of our question. The center of mass or centroid of the given geometry are located at a by 3 comma